Okay, so this is a real quick explainer video of what an F tree is, and it may end up with that name, it may end up with another name, and so if we take a look here, we can see that I've got a little bit of diversity going on. Like here, I've got a sequence of growth. You'll notice here that everything has like a slice missing, or not a slice missing, but like some of these have pieces missing. These have been recorded over time as I've been. These are structures that are grown, but over time, the code. I've been changing the parameters of the code and stuff like that to work with different types of possible growth patterns. So the underlying idea is just that there's patterns for everything, right? There's a bifurcation vector basically that gets sent in there that represents a bunch of different, like 6 different parameters about bifurcation and like the ratios of the speed of growth of each of the things that come out, so on and so forth. One parameter that I need to add onto it is when to stop bifurcating and when to stop growing. Also, that's another parameter that can be added into each of these growing tips. So the idea is that each of these are tips which grow and then they bifurcate at one point with a specific bifurcation pattern. You can see that this one has a rotation pattern when it's bifurcating, right? And these do too, but the rotation is slightly less, for instance. And if we look all the way over here, before I was just working with the skeleton or the armature of the tree, basically. I'm going to use this entire, like basically I've been using this frame setup. So this, you can look at this as like a growth projection matrix, right? So, but it also represents the path of the tips of the plants, like of each of these branches as they're growing. So the tips travel through space and they leave behind them a branch. And then basically the branch is inhabited by radial cells. And these radial cells are literally each one of these vertices that you see here. Each one is a radial cell that's been dropped. If you look at the top here, I've got the tops off of these things. This is a good example. You can see right there that there's like this cell just floating in the middle right there. Well, that's the tip. That's the growing tip cell. And then all of these cells are like the most recent ring that was just dropped off of to make this branch, right? And if we take a look at things in straight up wireframe mode, we can actually see that these things start growing inside. And I have yet to, so the cellular automata, they're basically linked to each other. Like you can pretty much see this grid of the wireframe as their links to each other. That's their link. That's their exact linkage neighborhood. That's the direct neighborhood on the surface of this growing thing. And you can't see it in this because it's just data, but there is a history of each cell growing from the center. So there's literally, if you take that history part apart programmatically, it is the rings of growth. So like you could technically chop one of these off. Like you can take one of these branches anyway. So if you were to just like take one of these branches completely off the tree, you could get information there. So one thing that I've got is right now I've got like all of this, the cellular automata, it works on, so this is a double cellular automata system, right? This is a system where you've got one cellular automata who's a tip, who's responsible for like branching and stuff like that, given a specific pattern that it needs to follow for branching. And then you've got the pieces, the radial cells, which are connected within each other in a specific pattern. There's a specific pattern of connection. It's not just a plus on that level. But right now, they're only connected to the one that's directly above them. So each one of these is connected to each other, which means that there's like vertical. So pretty much once these things can start sharing hormones, which they will, there will be vertical vertical channels that go up. And I still need to connect these cells. So I've got to be really careful about this connection scheme here, because I've pretty much got to match this circle to that circle, because they're both on the same. It shouldn't be too hard. I just take, because they're all just indexed pretty much the same exact way. So as long as the angle isn't too much, like, you can link these cells together, and they may not link, they may not, I don't know, who knows what's going to happen. But the point is that once they link together, then you'll start to see a smoothing of these junctions between them. But also you'll also see something that's like you'll see something in the hormonal exchange between these cells that's going to be happening. And I want to find a good way to visualize that in 3D. I'm learning how to do vertex coloring and stuff like that, so that should be pretty fun. And that should show you, like, in real time what's going on. These things can grow in real time. Right now I have them on a step system. So this is like, I recorded one of these every 4 steps, starting at 2 steps. So this is the 2-step one when it just like first started growing, and then that turned into this pattern. And I have in each of these trees, let's see, this is all open source stuff. So I have in each of these trees where are we scripting? There's a random seed, because there's a random vector that affects the cells, the growth of each of the cells right now. But what I'm going to be doing is replacing those with a randomly connected, like I'm going to be replacing the actual actions it does. So each cell has a grow function, right? And each slice has a grow function. And basically, the update function that sets everything, right? So that they can see like the past step of all of their neighbors, which is proper in cellular automata. And of course you've got the add neighbor function that, allows you to do that. But then you've got the distance to origin function, which just gives it a thing how to move to rest, which can happen. So, which I'm not actually using here right now. That was when I was doing some previous work with patterns. But the grow function is just a list of different functions, right? So basically, in our genetic code for growth, basically, I mean, this is not talking about the communication between cells. This is only talking about the growth of the cell itself. We can take the communication between cells and the hormones that can be passed from cell to cell. So there's other actions that a cell can do, like exchange hormone with one of its neighbors. And it would have to exchange a hormone with a specific neighbor, and then a certain amount of volume of that hormone. And I've got the hormones towards the bottom of this code right now. But, you've got a basic thing, hormone here. And that will be filled out. And so, so far I've seen a really good ability to grow a whole bunch of different things. And I've also seen the possibility to make it so that, like, I haven't even done yet this whole logarithmic, or not logarithmic thing, but I want to do basically what's called a bell curve or whatever for each of the parameters that are for each of these cells, and then each of the parameters for each of these slices, and each of the parameters for the tips, so that over the lifespan, because each of the cells in these, like the slices doesn't really matter too much, but the tips have an age and the cells have an age. So the tips will tell you how long they've actually like been growing. And I could probably say how many bifurcations it's had or something like that too, just to have data on that. But the tips will also tell you, like, so for instance, when a tip gives information to another tip, so like the tip, when it bifurcates, some of that information gets inherited by the two child tips, and some of it is set up in a way like it just gets these vectors that need to happen, right? And then down here in the make function, you've got, when it does bifurcate, man, lost it, don't know where it is. Oh, the bifurcation, there it is. Okay, so when it does bifurcate, it does a little bit of math here, like the speed is slowed down by the ratio and everything like that. So all of those ratios and everything like that, this function can be partly based off of age. So if I tie age to these curves that can happen over the period of life, that would allow each of those cells to like react to their hormones that are being passed back and forth, or pass specific hormones back and forth depending on like what age they are. And I can sort of specify that in the very beginning to like try to what I'm really trying to do is gender these things to be trees, but in the end I realized that there's a way to make any sort of like life form, like if you gave the ability for these cells to use a kinetic system and like move around, they could, and if you used some sort of a fitness function for your genetic algorithm that allowed them to, I don't know, base their success for going to the next generation on something like how well they were really able to move around. I mean, there's a lot of things, right? But then there's also the idea of creating like specific creatures that just all they do is pollinate, and seeing how this system genetically would react to that. So the first thing I have to do is parameterize everything from the tree standpoint and turn this make function into basically a tree class, and basically use the make function just to make a tree and have some of this stuff consolidated. Then I've got to take that, I've got to turn it into, I've got to make it so that A, the hormone system works between the cells, B, the cells do also grow, they also grow horizontally, and even their growth like stuff has to have that curve to it, right? So I have to parameterize and make it something that's like a little bit more clean as far as like how to add a parameter to this, and like what the curve over the cell's life is going to be based off of age, of how many growth steps the cell has. Now, okay, you might ask, well, if one growth step does like one little notch of these things, then I guess it's kind of like you don't really get to see the notch grow. Well, right, you could get to see the notch grow because there could be real-time interpolation of the notch growing from its initial point to here, and also interpolation of like things that the notch would grow. So the idea is also this. Now there can, because of that whole curve system that I'm talking about, based on age, well, the cells could differentiate into other things because the curves themselves over time, like for instance, the tip could differentiate into something besides just a tip, or a cell could differentiate into something that grows a specific way because it uses a different pattern of growth at this time in its age because of all of the ways that these curves go. So what that means is that, like, I was thinking about, okay, adding a fruit system to this and a leaf system and all this other crap, but why should I do that if I could just figure out how to fucking evolve leaves from a basic system, like a much more simple system that I don't have to add extra things on to make it into a tree? I should evolve trees from this system of growth by making the parameters more realistic as far as how each of the cells progresses through life, and the different types of cells. There are even cells that are on the inside, and technically if I do ray casting, these cells will not get light, so they might differentiate into something else, and they could even be connected to, like, they're definitely already connected to the main center cell here, when they're on the node that's in the very middle. I don't know if you can see down this shaft, but you can see some other stuff going on down here. There's this other cell that's in the center, and then there's like 2 cells going down this shaft, but the one that it's connected to is actually the one in the center. So the ones inside could actually turn out to, if they don't receive a lot of light, they could differentiate into something that helps with some sort of internal process or whatever. So literally, I was thinking about even taking those out, but I was just like, no, just make them more interconnected. And also, yeah, I mean, there's so many directions this thing can go, but for now, what I want to be focused on is just making the growth system complete so that it becomes something somewhat of just like a standard that the system can use for growing organisms, which just for right now happen to be trees. And I've got a whole root system, which basically the roots are literally the same thing as the tips. It's just that the roots are, the tips are the shoots are what you see, and the roots are under the ground, right? In horticulture type of terminology. But these things have like these, the roots will have tips that just have slightly different reactions to gravity and light. Plus, also they seek out resources and they can sense other roots. So the roots need to do like a little bit of a ray casting thing in front of them to try and sense other roots. Either that or just like I need to somehow, yeah, I don't know. I think Blender might have something built in to do this. Otherwise, I'm going to have to get into some deep math structures. But this has been a pretty fun trip so far, a coding adventure. So I'm going to keep it... yeah, I'm going to keep it going. Anyway, though, I think that's the video, and I'll have more on this later. I'm going to link the GitHub in the description, and please like and subscribe if you want this to go forward. I really want to make NF trees in a way that is eco-friendly. Like, they're NFTs that you can grow, that you can like turn into whatever you want through genetically modifying them in the genetic algorithm inside of like an ecosystem in games. It could become this standard for organic type of life or something like that, which could be pretty cool. I'm not trying to make anything out of this besides some really great tree NFTs that I definitely want to sell, because yeah. But besides that, there's really nothing. Like, I don't want to make this into a corporation. I don't want to do anything. I just want to make a DAO, like a proper one, the same type of DAO as like Cardano or Decentraland has, and allow that to control where a percentage of all of the royalties go to like save any sort of like tree organization and things like that. There's also a couple of other projects that I've been looking at. There's one called Plane. I'm gonna get in contact with that developer and see what's going on there. So anyway, though, any comments or whatever that you guys have as a community, please let me know. I think this has great potential, and I can't wait to see what happens when I hook up the genetic algorithm to this thing. It's going to be insane, and it's going to be a challenge just to see how I can get these things to differentiate properly and like to do what I want them to do, to still be trees or something like that. Who knows? And so yeah, I'm going to get the root system connected up, and a couple of other like little small things on these, and then that's that. So I hope you liked the video. Let me know in the comments below.